So in this video, we're going to go the other way around. We're going to go from component form into magnitude angle form. This way is a little bit, has two distinct parts to it. And you can imagine, one is finding the magnitude and the other is finding the angle. So it's a little more involved than the previous one, but not impossible. So for the most part, when we do this, in fact, yes, what we're going to do is we are going to ignore the negatives. So really, I'm dealing with 15.7 as my y component and 23.2 is my x. We can, in this process, ignore them for now because we're going to find a reference angle anyway, and then we're going to go back and remember that we're going to figure out that we're in the fourth quadrant. And by that, I mean this. If you didn't know this, right, you don't know this right now, how can you look at this and know that you're in the fourth quadrant? Well, your x is positive, that's over here, and your y is negative, that's down here. So that only happens in the fourth quadrant. So I know this is our answer, right, but it's helpful in this case to have the answer in front of us, kind of see where we're going. But the fact is that you could tell by looking at this what quadrant it's in. So let's say we start with that. So how do I go from that to the magnitude? Let's do that first. Well, remembering our drawing book before, if I know the components are positive 23, I'll say that's about here. I've been doing blue for the x component, haven't I? There we go. And the y component is 15, and we'll do that in red. Down maybe like that. Then the overall vector is like this. That's what I'm looking for, and I'm looking for its magnitude. I'm looking for the hypotenuse, aren't I? Right? And we'll call this vector A again. So here's vector A. So the magnitude, not worried about the direction, that's what those lines mean, of vector A, well, we've done this before. This is just a Pythagorean theorem. I have one leg, and I have another leg, and so that's going to be the x component squared plus the y component squared. And once again, don't worry about the negatives. Sometimes when you type in on the newer calculators, if you type in negative 15.7 and you hit, when you don't put in parentheses around it and you hit squared, it's going to give you a negative number and it's just going to make your life miserable. We don't need to worry about that in here because we'll sort that out. We've already noted to ourselves this is going to be the fourth quadrant. All right. So what do we do here? We got, well, magnitude is going to be 23.2 squared plus 15.7 squared. So 23.2 squared plus 15.7 squared equals, and then take the square root, and that's 28, we'll call it 28 even, which is what we would expect. So the magnitude of that vector is, in fact, 28 units, just like we expected to get. And by the way, you're going to get this a lot in this class, and I'll say it again many times, I'm sure. Having the answer in front of you, I have plenty of students over the years who will be like, well, why are we doing this if I already know the answer? The point is you're learning the process. So having the answer actually helps you and gives you immediate feedback. If you are like, well, it doesn't matter because I have the answer, and you don't do this, you're not going to do well. Okay, so we found the magnitude. Now what about this angle? Well, let's consider it. So if you know the x, sorry, I mean, I said x but was pointing at the y. If you know the x and the y, the two legs, how can I find that angle? So I have the opposite and I have the adjacent. We'll say I don't know this, right? So if I have the opposite and the adjacent, which trig function am I going to use? Let's do this in blue. So to find the angle, the reference angle I should say, Opposite and adjacent is going to be tangent. So what we know is that the tangent of the reference angle is equal to the opposite, that's going to be the y component, over the x component. It's always y over x. But we're after the angle. We're not after, we already know the components, we want the angle. So how do we go after an angle? If you've done the trig video, you know the reference angle is going to be the inverse tangent of, and now this is, I want to reiterate this, just use the positive values. So A, the value of the magnitude of the y component divided by the magnitude of the x component. Don't worry about any negatives. And if we do this, it'll give us the reference angle. So knowing what we know about those, we'll go to the calculator. And we will first do the y component, 15.7. Notice I'm ignoring the negative. Divided by 23.2. And then do the second or inverse tangent of that. You can call it 34.0, 34.1, or just call it 34 degrees is fine. And just like we would expect, the reference angle is 34 degrees. Now, once again, that means we're going to write this in magnitude component form. We're going to write that vector A is equal to 28 at 34 degrees, but we can't forget that it's in the fourth quadrant because we have a positive x and a negative y. And so I have to say that. Fourth quadrant. Or I could say, let's see, if the reference angle is 34, that would be 360 minus 34. I could also write that as vector A, there we go, equals 28 at 326 degrees, which is, if anybody that knows the angles knows that that's in the fourth quadrant, you don't have to worry about that. So there's two ways to write that answer. You're going to want to practice this a couple times to get good at it so that you can use it for the next few things we're going to do.